So we're going to look at combinations, which is similar to what we did with permutations. The key difference with combinations is that it's not regarding order. So we're going to start with this example where we have hamburgers bought from Wendy's and just looking at the total number of different burgers we could have if we're putting a certain number of toppings on. So for the first question here, the order of toppings really shouldn't matter because it doesn't matter if you put ketchup on first, followed by mustard, or mustard followed by ketchup. Then in question two, we're looking at if they offer a total of nine toppings and we're picking three of the toppings, how many possible burgers could we make? But here we are going to look at in order first. So we're going to use permutations like we saw the other day. So remember, N is always how many you're selecting from, P for permutations, and then we're selecting three. And so we can use the formula that's going to be N factorial over this difference, 9 minus 3 factorial, so 6 factorial. And then remember, if you don't have a calculator, this 9 factorial is really 9 times 8 times 7 times 6, all the way down to 1. And then 6 factorial is 6 multiplied all the way down to 1. So 6 on down is going to cancel. And then really, this 9p3 is just 9 times 8 times 7, or 504. But it's not likely, like I said, that that order is going to matter. So now we're looking at if the order does not matter. So we're going to see the formula for combinations here in just a second, and then we'll hop back to this example to do that calculation. So like I said, combinations is a selection of a certain number of objects from a total without regard to order. And we have our formula here for combinations. Its notation is similar to what we saw with permutations. We use a C instead for combinations. And then this part of the formula here is the same as the permutations formula. But the combinations should be fewer than the permutations, because if you were thinking about the hamburger problem and say your three toppings were ketchup, mustard, and cheese, if you were to order those, we could have ketchup, then mustard, then cheese, or you could have mustard, then ketchup, then cheese, and you'd have all of those different arrangements. Whereas the combinations is going to narrow that down. So we have to divide by this additional factor of r factorial to basically eliminate the repeats that we have in all of those permutations. So, if we want to answer this question here of selecting three toppings out of the nine without regard to order, we're going to do 9C3. And so we start to plug that in, or can plug that into the formula. It's going to be n factorial over this difference here still. So, still a 6 factorial, but then we have that additional factor of 3 factorial in the denominator. So really, we already know this 9 factorial over 6 factorial was the 504 divided by 3 factorial. So 3 times 2 times 1, or divided by 6. So combinations, we only have 84. And there's a combinations option on the calculator as well that I'll walk you through in the next table that we're going to fill in. So here we're just going to look at the number of combinations we have if we put 0 toppings out of the 9 on our burger, 1 topping out of the 9 on our burger, and so on. And then once we look at all of those options, we can determine how many different burgers we could potentially order just based on those number of toppings. So for the 0 toppings, there's going to be only one way you can order that because it's just a burger with no toppings. But we can use the formula. So our formula would be 9C0. And when we do that 9C0, you can use your calculator, and it works in the same way as the permutations does. So you hit the 9 button, and then you find your probability menu, that PRB, and then there should be an NCR option, and then the 0. And like I said, when you type that in, you should get a 1. We can fill in the remaining of the chart this way. So we have a 9C1 here. And again, if you use the calculator, it would be 9 and then hit that probability button, NCR, and then 1. There's 9 ways you can order a burger with 1 topping. And then we've got 9C2, which is 36. 9C3 is 84. 9C4 is 126. 9C5 is also 126. And then you're going to see some symmetry here. You were counting up to the 126 here. Now you're going to count down from the 126. This is going to be an 84, a 36, a 9, and then a 1. Oops, that's a 9C9. So then the total ways we can order a hamburger, well, we have one topping in one way, or I'm sorry, 0 toppings in one way, one topping in 9 ways, 2 toppings in 36 ways, 3 in 84. And then we just add all of those options together. So if I do that, I get 512 different burgers. So here's an example. I'll give you a second to read it. So here, when we read this problem, we need to start to think about whether order matters in our scenarios so that we know whether we use combinations or permutations. So here, it does have the word combination in the problem, but if it didn't, if we think about this, if we're just picking 4 companies to work on the project out of 16, order's not going to matter. If you're one of those 4 companies, you're selected, whether you were picked first or last. So we're going to use combinations here. There are 16 total companies to choose from, and we're picking 4 of them. So if we're going to use the formula here, it would be a 16 factorial in the numerator, difference between 16 and 4, so 12 factorial in the denominator, and that additional factor of r factorial in the denominator. So again, our numerator will cancel out some with the 12 factorial because we're going to cancel out the 12 on down. So up top, we really have 16 down to 13, and on the bottom, 4 on down to 1. So if I type that in, my numerator is 43,680, and my denominator is 24. So I have 1,820 different combinations that I could select 4 companies out of 16. Oops. So this is the same scenario, just to try it on the calculator. So it's still going to be a 16C4. And again, you type in the 16 first, and then you hit your probability button and select your NCR, and then type in the 4. And you should get the same thing that we got from the formula here, 1,820. So here's another scenario that we're going to use some of these formulas in. I'll give you a minute to read this one. So we just want to look at how many different 8-song playlists there are where the order does not matter. So that means we're going to use combinations. She has 50 songs total, and she's selecting playlists of length 8. And so we can use the formula, but I don't really expect you guys to do that every time. So we can just go ahead and type that in, and we get a very large number of playlists. Now in question 2, we're going to reduce this. We're only going to look at songs or 8-song playlists that have no songs by One Direction. So she has 50 songs total on her playlist. 15 of them are songs by One Direction. So now we only have 35 songs to select from. So we're going to do 35C for combinations, and then we're still selecting 8-song playlists. So again, type in the 35, select the NCR, and then option 8. And we can see that there are fewer playlists, but still quite a few. So the probability that none of the 8 songs is by One Direction is going to be the number of playlists with no songs by One Direction. That's our successes. So really, if I put it in the C notation, that was our 35C8 out of the total number of playlists. So that was 50C8, or the 23,535,820 divided by 536,878,650. So that probability is about 0.044. And then for the last one, we want the probability that exactly 2 of the songs on the playlist are by One Direction. So we are going to figure out the probability that we have 2 songs by One Direction. So that would mean that we had 2 out of the 15 One Direction songs. And then the rest were not One Direction. So there were 35 remaining songs. 6 of them would be selected. So again, this is the 2 songs. I'll say 2 1D, and then the 6 not 1D. So if I do 15 and then I select my NCR 2, and then because these numbers are getting so large, I can just do everything all in one step in my calculator. I can type in a multiplication sign and then do 35 probability NCR and 6. And this total product here would be 170,431,800. So this is the number of playlists that meet the criteria of 2 songs being One Direction and 6 are not. So to find the probability that 2 of the songs are by One Direction, that's my number of successes divided by the total number of 8-song playlists. So this answer to question 1, the 536,878,650. And so that probability is about 32%. The final thing that I want to walk you through here is this question 25 that was part of or is part of your homework assignment because it's a little bit different from some of the ones that we just saw. So I'll give you a second to read this one. So here where it says in how many distinguishable ways can the trees be planted, that means that the order is going to be important. If you plant an oak tree followed by a maple and then another maple, they would consider that being different from a maple followed by an oak. So we're going to use permutations here. So if I look, I have 4 oak trees, 8 maple, and 6 poplar. So in terms of my total number of trees, I have 18 total. So I can figure out the way I can plant all 18 of those trees with regard to order by taking 18p18. This is going to give me a really large number. It works out to be in scientific notation in the calculator. But this is going to be all of those different orders of 18 trees. But if I plant an oak tree first and then an oak tree third, if I were to flip those 2 oak trees and still plant them first and third, but just switch the 2 of them, that's not a distinguishable difference. So I have to divide by any repeats. So I have 4 different ways I can plant those oak trees out of 4. I have 8 different ways that I can plant those maple trees out of 8, and 6 ways for the poplar out of 6. So I'm going to divide by those repeats. So again, this is the total number of ways. These are my repeated. For that first one, it's the oak. These are my repeated maple. And these are my repeated poplar trees. So if I do this calculation, and again, because the numbers do get so large, I can do everything all in my calculator. So I can do 18p18, and then I can hit the divided by button and then open a set of parentheses for the denominator. But I do want to make sure I hold this whole denominator together in parentheses so that my calculator kind of keeps track of my order of operations. So then I would do 4p4 times 8p8 times 6p6. Close those parentheses. And then this whole expression here gives me, whoops, put my comma in the wrong spot there, 9,189,180 ways I can plant those trees.